Welcome. Today, we're diving into datum targets, a key concept in geometric dimensioning and tolerancing, or GD&T. Not all part surfaces are suitable as measurement references, especially in castings, forgings, or large welded assemblies. Datum targets solve this by designating specific points, lines, or areas for precise measurement, even on rough or uneven surfaces. We'll break down what datum targets are, why they matter, and how to use them effectively in your drawings. By the end, you'll know how to apply datum targets to ensure your parts fit and function as intended. Let's get started and see how these small features make a massive difference in manufacturing accuracy. Before we get to datum targets, let's clarify what a datum is in GD&T. A datum is a theoretically perfect point, line, or plane used as a reference for measurement. Think of it as your anchor. Datums provide the origin for all dimensional relationships, ensuring repeatable and consistent measurements. On a drawing, a datum feature is a real surface or feature that establishes this reference. For example, a flat surface labeled as datum A becomes the basis for measurement when placed on an inspection plate. The key datums ensure parts are measured and assembled consistently, directly relating tolerances to real-world function. Smart datum selection is what makes a design robust and easy to inspect. Using an entire surface as a datum works for simple machined parts, but not for rough, warped, or oversized components. Castings, forgings, and large sheet metal parts often have uneven or flexible surfaces, making them unreliable as datums. If you try to use these surfaces, the part may rock or sag, leading to inconsistent measurements. Datum targets solve this by specifying exact points, lines, or areas for contact, creating a stable, repeatable reference. For example, 3 target points can define a plane on a warped surface, ensuring consistent fixturing every time. This approach bridges the gap between theoretical datums and real-world manufacturing challenges. Datum targets are essential for accurate machining and inspection of imperfect parts. They let you build precision from imperfection. Datum targets come in 3 types: points, lines, and areas, each with its own symbol and use. Datum target points are single contact spots, shown as a crosshair symbol. 3 points define a stable plane. Datum target lines are straight contact lines, ideal for cylindrical or elongated features, depicted as a phantom line with a special symbol. Datum target areas are small regions, circular or rectangular, marked with a hatched area and a size in the symbol. Use points for irregular surfaces, lines for features needing linear contact, and areas for distributing force or protecting delicate surfaces. Each target is labeled with a letter and number, like A1 or B2, for clarity. The symbol's lower half shows the datum and target number. Area targets also specify size. Mastering these types and their symbols is crucial for clear, effective drawings. Choose the right type to match your part's geometry and fixturing needs. Indicating datum targets on a drawing is a systematic process for clear communication. First, identify the most functionally critical surfaces, often rough, unmachined areas on castings or forgings. Apply the 3-2-1 rule: 3 targets for the primary datum, A1, A2, A3, 2 for the secondary, B1, B2, and 1 for the tertiary, C1. Place targets as far apart as possible for maximum stability. Use the correct symbols. A circle divided by a line, with the datum letter and number in the lower half. Attach each symbol to the exact location on the part using leader lines. Crosses for points, phantom lines for lines, hatched areas for areas. Specify each target's location with basic, boxed dimensions. These are theoretically exact, with no tolerance. Consistent naming and clear placement ensure anyone can interpret your intent. This method locks down the part's orientation and origin for all subsequent measurements. Properly indicated datum targets eliminate ambiguity and ensure repeatable setups. Remember, clarity in your drawing is key to manufacturing success. Use basic dimensions for all target locations. With these steps, your design intent is unmistakable. Let's see datum targets in action with a pump casting example. The casting's rough, uneven surfaces make it impossible to use the whole bottom as a datum. Instead, we specify 3 datum target points, A1, A2, A3, on the bottom, spaced far apart for stability. These define the primary datum plane for fixturing. Next, 2 points, B1, B2, on a side surface establish the secondary datum, preventing rotation. Finally, a single point, C1, on a perpendicular face locks the last degree of freedom. With these 6 targets, the casting is fully constrained for accurate machining. This approach ensures every critical feature is machined in the right place, despite the part's imperfections. Datum targets are used across industries wherever parts have rough, warped, or oversized surfaces. In castings and forgings, they establish the first reliable reference for machining. For large plastic parts, like car dashboards, datum targets ensure consistent fixturing despite warpage. Automotive and aerospace industries use them on sheet metal and composite assemblies, where entire surfaces are too flexible to serve as datums. Welded structures also rely on datum targets to compensate for distortion and ensure accurate machining of critical features. In every case, datum targets bridge the gap between imperfect parts and precise manufacturing. They're the foundation for repeatable, high-quality production. To make your drawings clear and practical, follow these tips for specifying datum targets. Stick to the 3-2-1 rule. Don't over-constrain the part, or fixturing becomes difficult. Place targets as far apart as possible for maximum stability and minimal error. For area targets, balance size, large enough for support, small enough for practicality. Always use basic dimensions for target locations, no tolerances. Keep naming consistent all targets for a datum, share the same letter and sequential numbers. Collaborate with manufacturing and inspection teams to ensure targets are accessible and practical. Avoid ambiguous or confusing placement. Clarity prevents costly mistakes. Remember, a perfect scheme on paper is useless if it can't be implemented in the shop. Teamwork and clear communication make datum targets work in the real world. In summary, datum targets are essential for creating stable, repeatable reference frames on imperfect parts. They let you build precision from rough or warped surfaces by specifying exact points, lines, or areas for fixturing and measurement. We've covered the types, symbols, and step-by-step process for applying them, plus a real-world example and best practices. Datum targets are used everywhere from automotive to aerospace, ensuring parts are made and assembled with accuracy. By following the 3-2-1 rule, maximizing stability, and collaborating with your team, you guarantee your design intent is realized. Mastering datum targets sets you apart as a designer who delivers quality and precision. Keep practicing, and you'll confidently tackle even the most complex parts.